Somewhere in the room with you there is a clock, doing the most ordinary thing in the world. Now hold it beside these. A single particle crossed our entire galaxy in about 10 seconds. A ring 27 kilometers around is 3.5 meters long to the protons inside it. 10 miles of atmosphere measures 1 mile to the thing falling through it. And from a fast enough ship, the whole sky, every star in every direction, folds forward into a spot of blue-white light you could cover with one hand. Not one of those is something happening to a clock. Every one is something happening to the universe, and the faster you go, the less of it is left. So here is tonight's question. When you reach the speed of a light, why does the universe stop? Not slow, stop. By the end of tonight you will have the answer, and its last layer is a sentence about you, lying perfectly still. Get comfortable. If you enjoy having the ground quietly taken out from under you, a quick like and subscribe helps this channel reach more curious minds like you. Because by the end of this, sitting still will be the strangest thing you have ever done. Now, let's gently drift into this. There is a clock somewhere near you right now. It might be on a wall, or on a phone face down beside the bed, or ticking quietly inside a wristwatch you stopped looking at hours ago. It is doing the most ordinary thing in the world. It is counting seconds, one after another, at the only rate any clock has ever counted them. 1 second, then another second, then another. 1 second per second. That phrase sounds like a joke, and for the next hour or so, I want you to hold on to it anyway, because by the end of tonight it is going to mean something very different from what it means right now. Alongside that clock there is a room, and beyond the room a street, and beyond that a country, a planet, a star, a galaxy, and something like 93 billion light-years of universe in every direction you care to point. And underneath all of it, holding it together in your mind, is a picture so comfortable that you have almost certainly never examined it. The picture is this. The universe is a stage. It has a floor with fixed distances marked on it. It has a clock hung somewhere overhead that ticks for everybody at once. Things move around on that stage. Planets, light, people, spacecraft. And as they move, the stage itself does not change. The distance from here to the moon is the distance from here to the moon. An hour is an hour. You move across the stage faster or slower depending on what you're riding in, and the stage sits there, patient and unbothered, exactly the same for the person who runs across it as for the person who lies still. That picture is wrong. Not slightly wrong. Not wrong in some exotic corner of physics that only matters near a black hole. It is wrong here, in this room, tonight, and it has been wrong the entire time you've been using it. And the way it fails is stranger than almost anyone tells you, because the failure does not happen to you. It happens to everything else. Here is the question this whole night is built around, and I want to put it plainly before we go anywhere near an answer. If you could climb into a ship and accelerate and keep accelerating and get closer and closer to the speed of a light, what would happen to the universe outside your window? Not what happens to your watch. You've probably heard that part. Your watch runs slow, your hair greys more slowly, you come home younger than your twin. That is a real effect, and we are going to walk through exactly why it happens, and exactly how it has been measured. But it is the smaller half of the story, and it is the half everybody tells, and telling it first has hidden something much stranger underneath. Because the thing that changes most dramatically as you approach the speed of light is not you. It is everything that is not you. The distances ahead of you, the stars you were aiming for, the gap between where you left and where you're going, the duration of the trip itself, and in the limit, at the speed of light exactly, all of that stops. Not slows, stops. The universe outside your window shuts down and hands you your destination without letting a single moment pass in between. By the end of tonight you will know exactly why that happens, and the answer has 3 layers to it. The first layer is a piece of geometry so simple you could draw it on a napkin. The second layer is an experimental fact that has survived every attempt to break it for 120 years. And the third layer is a sentence about you, sitting still, right now, that I think is one of the strangest true things in physics, and I am not going to give it to you until the very end. Get comfortable. We're going to take the long way around. Let us start with what you already believe about speed, because it is worth being precise about the thing we're going to lose. You believe that speeds add. If you are on a train moving at 60 miles an hour and you walk toward the front of the carriage at 3 miles an hour, Then someone standing on the platform sees you moving at 63 miles an hour. If you throw a ball forward from that train at 50 miles an hour, the ball is doing 110 relative to the ground. This is so obvious that stating it feels almost rude. It is also something you have confirmed with your own body thousands of times. Every time you have walked up a moving escalator, every time you have thrown something from a moving car, every time you have run down the aisle of a plane, the world has agreed with you. Velocities add. You also believe that there is one present moment shared by everyone. Right now, as you lie here, there is a person in Tokyo doing something, and there is a rock on the surface of Mars sitting in the cold, and there is a star on the far side of the galaxy burning, and all of that is happening now. You might not be able to see it, and the light might take a long time to reach you, but the events themselves are simultaneous with this one. There is a universal now, a single sheet of the present sliding forward at 1 second per second, and everything in existence rides on it together. And you believe that distance is a property of the universe. The gap between the Earth and the Sun is about 93 million miles. That is a fact about the solar system. It does not depend on who is measuring it, or how fast they are going when they do. A ruler is a ruler. A mile is a mile. Whether you're standing still or moving at half the speed of light, the Sun is 93 million miles away, because that is simply how far apart those two objects are. And there is a fourth thing you believe, quietly, which is that the speed of light is very fast but not otherwise special. It is a big number. 299,792,458 meters every second, which comes out to about 186,000 miles per second, or a little over 670 million miles an hour. Fast enough to circle the Earth 7.5 times while you finish a single breath. Fast enough that in the time it takes light to cross the room you are lying in, nothing measurable has happened anywhere. There is a lovely unit for this that the computer scientist Grace Hopper used to hand out on pieces of wire. A nanosecond, 1/1000th of a second, is about 30 centimeters long. That is how far light gets in a nanosecond, roughly the length of your forearm. Hold your hands a foot apart and you are holding a nanosecond. But fast is not the interesting part. Fast is just a number, and the universe is full of large numbers. The interesting part is that this particular number behaves in a way no other speed in existence behaves, and that single misbehavior is the crack through which everything else falls. Every one of those three beliefs is false, not approximately true and slightly off at the edges. False. And they are all false because of one single experimental fact that nobody was looking for, that nobody wanted, and that has refused to go away for over a century. I want to be careful here, because there is a way of telling this story that makes it sound like a puzzle or a paradox, something clever that physicists enjoy for its own sake. It is not that. The consequences of this fact are running underneath your life continuously. They are inside the satellite network that tells your phone where you're standing. They are inside every particle accelerator ever built. They are raining through the roof of the building you're in right now, at a rate of roughly 10,000 particles a minute, and every one of those particles is a small proof that the stage does not sit still. We will get to all of it. But the question stays open until the end. Not what happens to your clock, what happens to the universe, why it folds, why it shuts, why when you finally reach the speed you have been chasing your whole life without knowing you were chasing it, everything outside simply stops. And to start pulling that apart, we have to go back to a basement in Cleveland in the 1880s, where two men spent years building an instrument to measure something that turned out not to be there. In a basement room at what is now Case Western Reserve University in Cleveland, Ohio, there is a slab of sandstone about 5 feet square floating in a trough of liquid mercury. The mercury is there so the slab can be turned smoothly, without vibration, by the pressure of one hand. On top of the slab is an arrangement of mirrors, folded back and forth so that a beam of light splits in two, runs about 11 meters out along one arm and 11 meters along another arm at right angles to it, bounces back, and recombines. When the two halves of the beam meet again, they produce a pattern of light and dark stripes. If one half of the beam took even slightly longer than the other, those stripes shift sideways, and you can see the shift through an eyepiece with your own eye. The year is 1887. The two men are Albert Michelson and Edward Morley, and they are trying to measure the speed of the Earth through the ether. The ether was not a foolish idea. It was the most reasonable idea available. Light had been shown to be a wave that had been settled decades earlier when Thomas Young sent a beam through two narrow slits and got an interference pattern that only waves can make. and every wave anyone had ever studied was a wave in something. Sound waves are pressure moving through air. Ocean waves are water moving. A wave is not a thing, it is a behavior that a medium performs. So if light is a wave, then light must be a wave in some medium, and that medium must fill all of space, because starlight reaches us across distances where there is nothing else at all. They called it the luminiferous ether, and they took it entirely seriously, and so should we. Here is the elegant part of the experiment. The Earth is moving around the Sun at about 30 kilometers per second, roughly 19 miles a second. If space is filled with a stationary ether, then the Earth is flying through it, and from the Earth's point of view there ought to be a wind, an ether wind, blowing past the planet at 19 miles a second. And light travelling along the direction of that wind should take a measurably different amount of time to complete a round trip than light travelling across it. It is the same reason a swimmer takes longer to swim upstream and back than to swim the same distance across a river and back, even though the total distance is identical. The current does not cancel out. It never cancels out. Michelson and Morley calculated what they expected. The fringe pattern should shift by about 4/10 of a fringe as they rotated the slab, a shift roughly 40 times larger than the smallest one their apparatus could see. They rotated it. They rotated it at different times of day to catch the Earth's spin. They rotated it at different times of year to catch the Earth's orbit. They rotated it in April and again in July. They measured nothing, not a small number, not an ambiguous number. The observed shift was under 2/100ths of a fringe, averaging below 1/100th, which within their precision was 0. The light did not care which way the Earth was going. That result has been repeated, refined, and hammered on for more than a century. Modern versions use cryogenically cooled optical resonators instead of mirrors on a stone, and they now constrain any directional difference in the speed of light to below 1 part in 10 to the 17th power. To put that in ordinary terms, if the speed of light varied with direction by even a fraction of a millimeter per second, we would have caught it by now. It does not. There is one more piece of evidence worth putting beside the laboratory work, because it comes from the other end of the scale entirely. When a gamma-ray burst goes off in a distant galaxy, it releases photons across an enormous range of energies at essentially the same instant. Those photons then travel for billions of years before reaching our detectors. If the speed of light depended even faintly on a photon's energy, that journey would act as the longest possible amplifier, and the high-energy photons would arrive noticeably before or after the low-energy ones. They arrive together, within milliseconds, after billions of years in flight. Whatever this number is, it is not negotiable at either end of the universe. We have since taken the point so seriously that we rebuilt our system of measurement around it. Since 1983, the meter has not been an independent unit at all. It is defined as the distance light travels in a vacuum in 1,299,792,458th of a second, which means the speed of light is no longer something we measure. It is something we have declared, and every ruler on Earth is calibrated against it. If some experiment tomorrow appeared to find a different value for the speed of light, the official interpretation would not be that light had changed. It would be that the meter had. So what does that leave you with? It leaves you with a fact that sounds simple and is not. The speed of light in a vacuum is the same for every observer, no matter how that observer is moving. Sit with what that actually demands. Suppose you are standing still and a beam of light passes you. You measure its speed, 186,000 miles per second. Now suppose you climb into an impossible ship and chase that same beam at 90% of its speed. Common sense says the beam should now be pulling away from you at only 10% of its former rate, the way a car doing 70 pulls away from a car doing 63 at a leisurely 7 miles an hour. Common sense is wrong. You measure the beam receding from you at 186,000 miles per second, the full amount, exactly what you measured standing still. Now turn around and fly directly into an oncoming beam at 90% of light speed. The beam should be closing on you at 190% of its normal rate. It is not. It arrives at 186,000 miles per second. The same number. Always the same number. You cannot gain on it, you cannot lose to it, and you cannot change it by moving. It is not a speed in the ordinary sense at all. It is a fixed feature of the world that happens to be expressed in units of distance over time. Every physicist alive in the 1890s knew this result and hated it. There were attempts to save the ether. George Fitzgerald in 1889 and Hendrik Lorentz independently in 1892 proposed that objects moving through the ether get physically squashed along the direction of travel by exactly the amount needed to hide the effect. It was an unashamed fudge, invented to make an unwanted zero go away, and it happened to contain the correct mathematics for entirely the wrong reason. Lorentz went further and worked out a full set of transformation equations, the equations we still use today, which still carry his name, while continuing to believe there was an ether, and that these were corrections applied to measurements made inside it. Then, in 1905, a 26-year-old technical expert, third class at the Swiss Patent Office in Bern, published a paper called On the Electrodynamics of Moving Bodies. It contains no citations. It does not mention Michelson or Morley. Albert Einstein simply took the awkward result and refused to explain it away. He built the whole thing from two assumptions and nothing else. The first assumption is that the laws of physics are the same for everyone moving at a steady speed. There is no privileged frame, no cosmic stationary point, no way to tell from inside a smoothly moving room whether you're moving at all. This one is uncontroversial and had been understood since Galileo. The second assumption is the one that cost you everything. The speed of light in a vacuum is the same for every observer. Full stop. Not approximately, not on average, for everyone. Einstein's move was to treat that not as a mystery requiring a mechanism, but as a starting point requiring consequences. And the consequences arrive immediately, because a speed is a distance divided by a time. If two observers moving relative to one another must both get the same answer for that division, and they are demonstrably not covering the same distances, then the only way out is that they are not sharing the same times either. One or the other has to give. What relativity says is that both give, that distance and duration are not fixed background properties of the universe, but quantities that shift, together and by exactly compensating amounts, depending on who is measuring them. And before we move on, it is worth noticing how close this strangeness already is to you. The magnet on your fridge works because of relativity, not as a metaphor, literally. Magnetism is what the ordinary electric force between charges looks like after you account for the fact that some of those charges are moving, and the correction that turns one into the other is the same correction we are about to derive. The electrons drifting through a wire move at a fraction of a millimetre per second, which is slower than a growing fingernail, and even at that speed the relativistic effect is strong enough to hold a piece of paper against a steel door. Every compass needle that has ever pointed north has been running on the thing that Michelson and Morley failed to find, which is a lovely abstract sentence, and it means nothing until you see it happen. So let us build the simplest possible clock and watch it break. Take two mirrors and hold them facing each other, one above the other, about a foot apart. Send a single particle of light bouncing between them, straight up and straight down, forever. That is a clock. It is the simplest honest clock anyone has ever designed, because it has no gears, no spring, no quartz crystal, nothing that could be jolted or worn or influenced by anything except the geometry of the situation. One bounce is one tick. Light crosses a foot in about a nanosecond, so this clock ticks about 1 billion times a second, and the only thing that could ever change its rate is a change in the distance the light has to travel or a change in the speed at which light travels. The speed at which light travels cannot change. We have just spent a long time establishing that, so hold that fixed and watch what happens. Imagine you're standing on a platform holding one of these clocks. Above you the photon leaves the bottom mirror, crosses the gap, strikes the top mirror, and comes straight back down. Up, down, up, down. Each round trip is a tick, and the ticks are perfectly even, and there is nothing more to say about it. Now a ship goes past you, moving parallel to the platform at some enormous speed, and inside the ship a pilot is holding an identical clock, built to the same specification, mirrors the same distance apart. She's watching her photon go up and down, ticking exactly as yours does. Nothing about her experience is unusual. She's sitting in a chair in a quiet room with a clock in her lap. Stay in that scene for a moment, because it is worth living in rather than being told about. You're standing on the platform. It is night, and the air is cold enough that you can see your breath, and the clock in your hands is a small glass column with a mirror at each end, and a bead of light travelling between them. You can hear it. Each bounce makes a faint click, 1 billion times a second smoothed into a low, steady hum, and the hum is the most reliable sound in the world. The ship comes in from your left. It does not roar, because it is moving too fast for sound to precede it, and there is nothing here to carry sound anyway. It simply is not there, and then it is there, filling the whole left side of your vision, and through a long lit window you can see the pilot in her chair with the twin of your clock resting on her knee. You watch the bead of light inside her column. It is not going up and down, it is going up and forward, laying down a long shallow zigzag as the ship carries the mirrors out from under it, and the faster the ship travels the shallower and longer each stroke becomes. You know exactly how fast that bead is allowed to move. You know it is not allowed to move any faster to make up the extra distance, and so you watch her clock and you count and you find that her ticks are arriving more slowly than yours are. And then you look up at her face, and she is looking back at you, and she is counting your clock, and she is finding exactly the same thing. But you're watching her clock from outside, and from where you stand, that photon is not going straight up and down. It cannot. By the time it reaches the top mirror has moved forward because the whole ship has moved forward, so the photon has to travel diagonally, upward and forward at the same time, to catch it. Then the bottom mirror has moved forward too, so the return trip is another diagonal, downward and forward. From your position on the platform, that photon is tracing a long zigzag through space, a stretched out letter V, over and over, leaning further and further forward the faster the ship goes. And a diagonal is longer than a vertical. That is not physics. That is a fact about triangles that has been true since before anyone thought about light at all. The hypotenuse is longer than the leg, so the photon inside the moving clock is covering more ground per tick than the photon inside your clock is. Here is the trap closing. There is one obvious way out of this. The photon in the moving clock could simply go faster and cover the longer diagonal in the same amount of time. That would fix everything. Both clocks would tick together, everyone would go home happy, and this video would not exist. But the photon cannot go faster. That is the whole content of part 2. It goes at exactly the same speed as the photon in your clock because every photon everywhere goes at exactly the same speed, measured by anybody. It has more distance to cover, and it is not allowed to hurry. Therefore the tick takes longer, not appears to take longer, takes longer. The moving clock runs slow, as measured by you, by exactly the ratio between the diagonal and the vertical. Now look at the same scene from the pilot's chair, because this is where most people's intuition finally gives out. From inside the ship she sees her own photon going straight up and down, ticking normally, because in her frame the mirrors are not moving anywhere. And when she looks out of the window at your clock on the platform, she sees your photon tracing a diagonal, because from her perspective the platform is the thing rushing past. Your clock is the slow one. She's not making a mistake, and neither are you. There is no experiment either of you can perform that will settle which of you is really moving, because the second postulate said there is no such thing as really moving. Take a moment with that, because it is genuinely the hardest sentence in relativity. Two people, two identical clocks, and each one correctly measures the other's clock as running slow. That sounds like a flat contradiction, and it is not, and the reason it is not is that the two of you also disagree about which distant events are happening at the same moment. You're not comparing the same pairs of readings. There is no shared sheet of the present sliding forward for both of you. There is your now, and there is her now, and they are tilted with respect to each other, and the tilt is exactly enough to keep the books balanced. Let us put a number on the stretch. The factor by which the diagonal exceeds the vertical is 1 divided by the square root of 1 minus the speed squared over the speed of light squared. Physicists call it gamma, and every strange thing in this video is that one expression wearing a different hat. You do not need to do the algebra. You need the shape of it, and the shape of it is what nobody prepares you for. At walking pace, gamma is 1.00000000000000000011. 16 zeros before anything happens. If you walked continuously for 80 years, you would end up a few hundred nanoseconds younger than someone who never got up. In a commercial airliner at about 560 miles an hour, gamma is 1.00000000000035. A career pilot with 20,000 hours in the air comes home a few hundred microseconds younger than an identical twin who stayed on the ground. It is real. It is also less than the blink of an eye spread across a lifetime. On the International Space Station, moving at about 17,000 miles an hour, gamma is 1.0000000033. Astronauts genuinely return from long missions younger than they would otherwise have been, by a few milliseconds. That is the current human record for time travel, and it is measured in thousandths of a second. Voyager 1, the fastest object ever to leave the solar system, is doing about 17 kilometers a second. Gamma is 1.0000000016, the fastest thing we have ever thrown, and relativistically it is standing still. The Parker Solar Probe, at its closest approach to the Sun, hits about 430,000 miles an hour, the fastest any human-built object has ever moved. That is 0.06% of light speed. Gamma is 1.00000002. Now watch what happens when we stop using vehicles and start using fractions of light speed. At 10%, gamma is 1.005, half a percent. At 50%, 1.155. At 86.6%, gamma is exactly 2. Clocks at half rate, distance is halved. At 90%, 2.29. At 99%, 7.09. At 99.9%, 22.4. At 99.99, 70.7. At 99.999, 223. At 99.9999%, 707. Look at the shape of that. Getting from a standstill to 86% of light speed, an achievement so far beyond us it is barely worth discussing, buys you a factor of 2. Getting from 99.9% to 99.9999%, a change of about 1 part in 10,000 in your speed, buys you a factor of more than 30. Every effect in this story is crammed into the last thin sliver of the range, and the whole of human experience takes place at the flat end of the curve where nothing happens at all. That is why none of this is obvious. We evolved on the boring part of the graph. But every word of that was about clocks, and I promised you at the start that clocks are the smaller half of the story, and that the real question is what happens to the universe. We now know the ticking slows. We still have no idea why the world outside should stop. To find that, we have to go and look at the one place where something has actually made the journey. About 10,000 particles are passing through your body every minute. They are called muons. They weigh about 200 times what an electron weighs, and each one is going roughly 99.5% of the speed of light. They pass through you the way you would pass through fog. They pass through the roof, through the floor, through the foundations, and a good number of them keep going for 100 meters into solid rock before they come apart. You have never noticed one, and you will never notice one, and every single one of them is a small piece of evidence that the universe does not work the way you think it does. Here is why they are evidence. A muon is unstable. Left alone, at rest, it survives on average about 2.2 microseconds, 2 millionths of a second, before it decays into an electron and a pair of neutrinos. That is not an estimate, it is one of the better measured quantities in particle physics, and muons are not made near the ground. They are made about 15 kilometers up, roughly 10 miles overhead, when a cosmic ray from somewhere in the galaxy slams into the top of the atmosphere and shatters into a spray of debris. So do the arithmetic the way your intuition demands. 2.2 microseconds of life, at very nearly the speed of light, gives you a range of about 660 meters, 2,000 feet. That is how far a muon should get before it decays. It has 10 miles to cover. It should not be even remotely close. If you calculate how many should survive the trip down, the answer is that essentially none of them do. The survival fraction is something like 1 in 10,000 of what actually arrives. They arrive anyway, in quantity, constantly, through your roof and through you. In 1962, 2 physicists at the Massachusetts Institute of Technology decided to make that arrival into a measurement precise enough to settle the matter, and they did it in the most physical way imaginable. David Frisch and James Smith hauled a scintillation counter, a heavy cabinet of electronics roughly the size of a wardrobe, up Mount Washington in New Hampshire to the observatory at 1,917 meters. Mount Washington has some of the worst weather recorded anywhere in the continental United States. The wind on that summit has been clocked at over 200 miles an hour. They set the counter up in the cold, tuned it to register only muons within a particular range of speeds, and started counting. It is worth pausing on how ordinary the apparatus was. A scintillation counter works by using a block of material that emits a tiny flash of light when a charged particle passes through it, and a photomultiplier tube that turns that flash into a countable electrical pulse. There is no exotic technology anywhere in it. The muons announce themselves one at a time, as clicks, and you sit there and you count the clicks, and after an hour you have a number, 563 an hour at the summit. a soft, steady rain of particles that had already lived much longer than they had any right to. Then they took the same detector down to sea level in Cambridge, Massachusetts, set it up again, and switched it on. If the world worked the way the arithmetic said it should, that 6,000-foot descent should have killed almost all of them. The predicted count at sea level, without relativity, was about 27 an hour. The counter read 412. They did not find a subtle discrepancy that needed statistics to tease out. They found that the muons had simply refused to die on schedule, by a margin of more than a factor of 15, and the margin was precisely what the gamma factor for those particles predicted. They filmed the whole thing for a teaching film, which is a detail I find quietly wonderful. The structure of time settled by two men, a counter, and a mountain, and then packaged up so undergraduates could watch it on a projector. There is a version of this experiment that predates the mountain by nearly a quarter of a century and gets almost no attention. In 1938, Herbert Ives and G.R. Stilwell fired a beam of fast-moving hydrogen ions down a tube and looked very carefully at the colour of the light they emitted. Relativity predicts a particular kind of Doppler shift for a moving source, one that survives even when the source is moving directly across your line of sight, where ordinary Doppler shifting would give you nothing at all. That transverse shift is time dilation showing up as a colour. Ives and Stilwell found it, and the strange footnote is that Ives himself never accepted relativity, and spent years arguing against it. He performed one of the first direct confirmations of the theory while believing it was wrong. Modern storage ring versions of the same measurement have since confirmed the effect to within a few parts in a billion. Particle physics has been living inside this result for so long that it has stopped being remarkable there. Unstable particles circulating in storage rings survive exactly gamma times longer than their rest lifetimes. Not approximately, not on average across a good run, but every run, every decade, to within about a part in 1,000 in the dedicated muon experiments at CERN. If time dilation were not built into the design assumptions, the beams would empty before the experiments could take data, and nothing in the field would work at all. Muons are the cheapest proof, but they are not the only one, and they are not the most bureaucratic. In October of 1971, Joseph Haffel and Richard Keating bought a set of airline tickets, including famously seats for the equipment, and flew 4 cesium beam atomic clocks all the way around the world, first heading east and then heading west. Back at the United States Naval Observatory, a reference set of identical clocks stayed put and kept counting. Flying east, with the Earth's rotation, relativity predicted the travelling clocks should lose 40 nanoseconds, give or take 23. They lost 59, give or take 10. Flying west against the rotation, the prediction was a gain of 275 nanoseconds, give or take 21. The observed gain was 273, give or take 7. Think about what that means as an image rather than as data. 4 clocks left a building in Washington together, showing the same time. They came back showing different times, not because any of them was broken, not because any of them had been jostled, but because they had taken different routes through the world, and the number of seconds along those routes was different. When they were placed side by side again, they disagreed, and every one of them was right. There is a small human detail in the Haffel and Keating story that I like more than the numbers. They did this on a shoestring. The whole experiment cost about $8,000, most of which went on the plane tickets, and the clocks flew as ordinary passengers with their own seats and their own boarding passes. 2 physicists and 4 heavy grey boxes going around the world twice to find out whether a second is the same everywhere. And then there is the version of this that is in your pocket. The satellites of the Global Positioning System orbit at about 20,200 kilometres, moving at roughly 3.9 kilometres per second. 2 relativistic effects act on their clocks at once, and they pull in opposite directions. Because the satellites are high up, where the Earth's gravity is weaker, their clocks run fast by about 45 microseconds a day. Because they are moving quickly, their clocks run slow by about 7 microseconds a day. The net result is a gain of about 38 microseconds every day. 38 microseconds sounds like nothing at all. But a positioning system works by timing radio signals, and light travels about 30 centimetres in a nanosecond. So 38 microseconds of clock error translates into roughly 11 kilometres of position error, every day, cumulatively. If the engineers who designed the system had not built the correction in from the start, and there was at the time a genuine argument about whether to bother, Then every navigation app on Earth would drift about 7 miles off target in the first 24 hours and keep going. And there is one more thing worth saying about the satellites, because it is the part that always lands. Those satellites are not exotic. There are about 30 of them. They have been up there for decades, and they are being used right now by aircraft, shipping, farm machinery, financial trading systems, and the phone within arm's reach of you. Every single one of them is running on the assumption that the present moment on board a satellite is not the same present moment you're having down here, and that the difference is 38 millionths of a second a day in a specific direction forever. This is not a philosophical position anyone holds. It is a line in an operations manual. You do not have to leave the ground for this either. In 2010, physicists at the National Institute of Standards and Technology in Colorado used a pair of aluminium-ion optical clocks, accurate to about 1 part in 10 to the 17th, to measure time dilation from a speed of roughly 10 meters per second. That is a fast jog. They also measured the gravitational version by raising one clock 33 centimeters above the other, about the height of a stack of books on a desk, and watching it pull ahead. At that point, the effect stops being astrophysics and becomes something you could demonstrate on a kitchen table if the kitchen table cost a few $1,000,000. So the ticking is real, measured, and engineered around. And every one of those experiments describes what a stationary observer sees happening to a moving clock. Every one of them is the outside view. Nobody has yet asked the muon what it thinks happened, and when you do, the whole thing turns inside out. Put yourself inside the muon. It is a strange place to stand, but it is the most important seat in this entire video, so take it. You are born about 10 miles above New Hampshire, in a shower of debris from a collision you did not see. You have, on average, 2.2 microseconds to live, and that is not a punishment or a hardship. It is simply your ordinary lifespan, the same one every muon has ever had. Your internal clock is not running slow. Nothing about you has been stretched or slowed or granted a reprieve. You feel nothing unusual whatsoever, because there is nothing unusual to feel. You are not moving from where you sit. The world is moving. The Earth is coming up at you at 99.5% of the speed of light, and you are hanging in space watching it arrive. And here is what you find. You live your ordinary 2 microseconds. You decay right on schedule, exactly as unstable things do. And in that time, you cross the entire atmosphere and reach the ground. You do not cross 10 miles. From where you are sitting, that column of air is not 10 miles thick. It is about 1 mile thick. The mountain got shorter. That sentence is the hinge of this whole night, so let me say it again with the emphasis in the right place. Nothing happened to the muon. Nothing was granted, extended, slowed, or saved. What changed was the world in front of it. The distance it had to cover shrank, by exactly the factor that a stationary observer would have called time dilation, and from inside the muon's frame there is no time dilation at all. There is only a universe that has become dramatically thinner in the direction it is travelling. This is also, incidentally, why the muon story is usually told backwards, and why the backwards version has done real damage to people's understanding. Nearly every popular account says that the muon lives longer because it is moving fast, as though speed were a kind of preservative, and the particle were being handed extra seconds by a generous universe. That framing puts all the strangeness inside the traveller and leaves the world alone, which is exactly the wrong way round, and it is the reason so many people come away from relativity, thinking it is a theory about clocks being unreliable. It is not a theory about clocks. It is a theory about the shape of the thing the clocks are moving through. This is length contraction, and it is the half of relativity that almost never gets told properly. Time dilation is what a moving object looks like from outside. Length contraction is what the outside looks like from a moving object. They are not two effects. They are one effect described from the two available seats, and the arithmetic that governs them is the same single expression. The same gamma, the same square root, the same curve that stays flat until it goes vertical. And they have to be one effect because otherwise the universe would be inconsistent, and the universe is many things, but it is not that. Think about the muon again. From the ground, we say, the muon lived 15 times longer than it should have, and therefore crossed 10 miles. From the muon it says, I lived exactly as long as I should have, and the distance was only 1 mile. Both accounts end with the same muon hitting the same detector at the same place. If the two effects were not locked together by the identical factor, the two accounts would predict different outcomes, and one of them would be wrong, and we would have caught that a century ago. So the reason to care about this is not that it is a nice piece of symmetry, it is that the question has moved. For 4 parts we have been asking what happens to a traveller's clock. From here on, we are asking what happens to the traveller's universe, and the answer is that it changes shape. Let us be precise about how. Length contraction acts only along the direction of motion. If you are travelling toward a star, the gap between you and that star shrinks. Everything else about the geometry, everything perpendicular to your path, is untouched. A sphere becomes a flattened disk rather than a smaller sphere. A cube becomes a slab. A galaxy you're flying through edge-on becomes a sheet. The universe does not shrink around a traveller like a balloon losing air. It compresses along one axis, like a book being closed. At 10% of light speed, the 4.24 light-years to Proxima Centauri would measure 4.21 from aboard your ship. Nothing to notice. At 50%, it is 3.67 light-years. At 86.6%, it is exactly half, 2.12. At 99%, gamma is 7.09, and the gap has become about 7 months of light travel. At 99.99%, it is under 23 light days. At 99.9999%, the nearest star is about 2.5 light days away, which is roughly the distance from here to Saturn. Here is a way to feel it rather than compute it. Imagine you are the one flying, and imagine that instead of a star you're aiming at a very long ruler laid out in space. A ruler 4 light-years long, with a mark every light week, floating still against the background stars. From a standstill you can count the marks. There are 208 of them. Now start moving along the ruler and keep accelerating. The marks do not blur and they do not disappear, and the ruler does not break. It gets shorter. The marks crowd toward each other evenly, all the way down its length, and the far end comes toward you not because it is moving, but because the space between the marks is measuring less than it did. At 99% of light speed, that 4 light-year ruler is a little over half a light-year long from where you sit. You could watch the entire thing pull in like a concertina and never see anything move at all. You have not moved Proxima Centauri. It is exactly where it was. But the distance between you and it is not a property of Proxima Centauri, and it never was. It is a property of the relationship between you and Proxima Centauri, and you have just changed that relationship by pressing an accelerator. I want to be careful here, because there is an obvious objection, and it is a good one. Surely you might say, this is just about measurement. Surely the real distance is still 4 light-years, and the fast-moving ship is simply getting a distorted reading. The way a ruler held at an angle gives you the wrong answer. That is not what is happening. There is no privileged ruler. There is no observer standing outside the universe with the true numbers written down. Every measurement of that distance ever made was made by someone in some state of motion, and none of those states of motion is the correct one. The 4.24 light-year figure is the distance measured by an observer at rest relative to both stars, which is a perfectly good frame, and is also just one frame among infinitely many. The ship's number is not a distortion of the true value. It is a different true value, and the reason we find that so hard to accept is that we have all spent our lives at the flat end of the curve, where every frame gives the same answer to 14 decimal places, and where it therefore looks exactly as though there is one true distance that everyone agrees on. Our intuition about the fixed stage was not built by observing the universe. It was built by observing a very small and very slow corner of it. Once you have taken this on board, some very old puzzles resolve themselves quietly. The famous twin paradox, for instance. One twin flies to a distant star and back at high speed and returns younger than the twin who stayed home, stops being paradoxical the moment you realize there is nothing symmetric about the two journeys. The traveller turned around. Turning around means changing frames, and changing frames means changing what counts as a distance and what counts as a duration halfway through. The stay-at-home twin never changed frames at all. The two of them did not experience the same trip from opposite ends. They took two genuinely different paths through space-time, and the number of seconds along a path depends on the path. That is all it has ever been. There is another old confusion worth clearing because it will matter later. If you photographed a relativistic object as it flew past you, you would not see it squashed. You would see it apparently rotated. This is the Terrell-Penrose effect, worked out independently by James Terrell and Roger Penrose in 1959, more than half a century after Einstein's paper, and it exists because light from the far side of a passing object left earlier than light from the near side, so a photograph is assembling parts of the object from different moments. For 50 years, every physicist on Earth had confidently said you would see a moving object contracted. Every one of them was wrong about the seeing, while being entirely right about the measuring. Contraction is real. Photographing it is a separate and more subtle problem. It is worth noticing that this shrinking has no flaw written into it anywhere. The formula does not say the distance contracts down to some minimum and then holds. It says the distance is divided by gamma, and gamma has no upper limit. Feed in a fast enough speed and any distance in the universe comes out as small as you like. A light year, a meter, a hair's width, less. The equation is entirely comfortable with that. Whether the universe is comfortable with it is a question we will have to come back to near the end of tonight, and the honest answer is that nobody knows. So the muon's account stands. Nothing happened to me. The world got thinner, and if a distance can be cut to a tenth by going fast enough, the obvious next question is how far the cutting goes. Where does it stop? What is the smallest a universe can get? To find out, we need to visit the one machine on Earth where this is not a thought experiment but a line in the engineering specification. About 100 metres beneath farmland on the border between France and Switzerland, there is a circular tunnel 26.7 kilometres around. It is roughly the size of the ring road of a mid-sized city, and if you walked it at a steady pace, it would take you the better part of 5 hours. It is lined with more than 1,200 superconducting magnets cooled to 1.9 Kelvin, colder than the empty space between the galaxies, and inside those magnets runs a pipe emptier than the space around the moon, and inside that pipe run protons. This is the Large Hadron Collider, and it is the largest machine human beings have ever built. During its second operating run, each of those protons carried 6.5 trillion electron volts of energy. That corresponds to 99.9999991% of the speed of light, and a gamma factor of about 7,460. Since the upgrade for the third run, the beams carry 6.8 trillion electron volts each, and gamma is a little over 7,500. It is worth understanding why the number is stuck so close to 100%, because it explains the whole feel of the machine. The energy you pour into a particle does not go into making it faster once it is already near light speed. It goes into gamma. Doubling the energy of an LHC proton does not double its speed. Its speed changes in the 9th decimal place. It doubles the factor by which its clock slows and its world contracts. Engineers at the collider do not talk about how fast the beam is going, because the answer is always the same boring string of nines. They talk about energy, because energy is the thing that is actually changing. The protons themselves begin their journey somewhere unglamorous. They start as a small bottle of ordinary hydrogen gas, roughly the size of a fire extinguisher, which is enough to supply the collider for years. The gas is stripped of its electrons, and what is left, bare protons, is fed through a chain of 4 progressively larger accelerators before it ever reaches the main ring. By the time a proton enters that final tunnel, it has already been passed through machines built in the 1950s, the 70s, and the 80s, each one handing it on to the next like a relay. Now do to that number what we did in part 5. Do not ask what happens to the proton's clock. Ask what the tunnel looks like from the proton. 26,700 meters divided by 7,460 is about 3.6 meters, the largest machine ever constructed by our species, the thing that took 10,000 people and 2 decades and several billion euros to assemble. The ring you would need 5 hours to walk around is, to the particles it exists to accelerate, about the length of a small car. A proton in that beam is not going around a 27-kilometre circle. It is going around a loop it could see both ends of, and it goes around it 11,245 times every second. That is not a figure of speech. It is an operating parameter, and it is why the beam has to be steered by magnets rather than by anything mechanical, because nothing mechanical can respond 11,000 times a second. A beam is typically kept circulating for something on the order of 10 hours before it is dumped. In 10 hours at that rate, a single proton covers roughly 10 billion kilometres, further than the distance from here to Neptune and back, several times over, inside a tunnel underneath a Swiss vineyard. There is also a lovely inversion buried in the 11,000 laps figure. From the laboratory's side, the proton is racing around a huge ring at an unimaginable rate. From the proton's side, it is barely moving at all through a very small loop, and what is racing is the clock on the wall outside. 10 hours of beam time in the control room corresponds to something like 5 seconds of proper time for the proton. The night shift at CERN lasts, for the particles they are looking after, about as long as it takes to tie a shoelace. Here is the part that moves this from curiosity to hard engineering fact. When the collider runs lead nuclei instead of protons, gamma reaches roughly 2,700 per nucleon. A lead nucleus is, to a good approximation, a sphere. At that gamma, in the reference frame of the detector, it is not a sphere. It is a disk, flattened along its direction of travel by a factor in the thousands. Physicists call it a pancake, and they draw it that way in the diagrams, and they write it that way in the simulation code. They do not do this because it is a nice interpretation. They do it because if you model those nuclei as spheres, the predictions come out wrong. The distribution of particles produced in the collision, the geometry of the overlap region, the shape of the debris that sprays into the detectors, none of it matches the data unless the nuclei are treated as flattened sheets meeting flattened sheets. The same is true at the relativistic heavy ion collider at Brookhaven on Long Island. Length contraction is not an interpretation that physicists overlay on the results. It is a line in the software, and if you delete the line, the software stops describing reality. That is worth sitting with for a second. Somewhere in a code repository in Geneva there is a function that takes the shape of an atomic nucleus and squashes it, because the universe squashes it, and if the function is removed, the predictions fail. The strangest claim in this video has been reduced to a maintenance dependency. It also gives us the first genuinely usable answer to a question people ask constantly, which is what any of this would feel like. The answer, for the proton, is nothing. There is no wind, no pressure, no sense of speed. Nothing inside a moving frame reveals that it is moving, because the first postulate forbids it. If you could ride that proton, you would look around and find yourself in a perfectly ordinary short tunnel, with an ordinary loop and an ordinary set of magnets, and the only clue that anything unusual was going on would be that the world outside the tunnel appeared to be in an enormous hurry. There is a nice small consequence of all this that rarely gets mentioned. Every particle physicist who has ever designed a beamline has had to think in 2 geometries at once. The laboratories, in which the apparatus has its blueprint dimensions, and the particles, in which it does not. The 2 descriptions never conflict, because they are locked together by gamma, but they are genuinely different descriptions of the same hardware. A component that is 4 meters long on the workshop floor is 0.5 millimeter long to the thing passing through it. Both numbers are used, daily, in the same building by the same people, and nobody finds this remarkable anymore. There is one more number here that I think is the best single illustration in all of particle physics. From the proton's frame, the 8 1/3 light minutes between the Earth and the Sun, the distance sunlight takes over 8 minutes to cross, measures about 67 milliseconds of light travel, 20,000 kilometers, less than twice the diameter of the Earth. That is what the solar system's most familiar distance looks like from inside a beam pipe under a French field. And notice what has quietly happened over the last 2 parts. We began with clocks running slow, which is odd but survivable. We have arrived at distances being divided by thousands, at a machine that is 3 meters long to its own contents, at the gap between the Earth and the Sun compressed to a fraction of a second. The universe is not staying still while we accelerate. It is folding, but it is still there. At gamma of 7,000, the tunnel is short, not absent. There is still a loop, still a distance, still an interval of time between one lap and the next. We have not answered the question we started with. We have only established that the folding is real and that it has no obvious flaw. So let us stop for a moment, put the pieces on the table together and look at what we actually have. Let us step back for a moment and put the pieces down on the table side by side and look at them. We started with a comfortable picture. The universe as a stage that does not move, with fixed distances marked on the floor and one clock hung overhead for everybody. We have now taken that apart in 3 separate places. The first piece is an experimental fact that nobody wanted. The speed of light in a vacuum is the same for every observer, regardless of how fast that observer moves and regardless of how fast the source moves. Michelson and Morley went looking for the opposite and found nothing, and 140 years of increasingly precise instruments have kept finding nothing, down to 1 part in 10 to the 17th. There is no way to gain on light, and no way to lose to it. The second piece is what that fact does to a clock. Because a speed is a distance divided by a time, and because that particular division must give the same answer to everyone, two observers in relative motion cannot agree about both distances and durations. Build the simplest possible clock, two mirrors and a photon, and the geometry does the rest. The photon in a moving clock traces a diagonal. A diagonal is longer than a vertical, and the photon is not permitted to hurry. The moving clock runs slow by a factor of gamma, and the muons falling through your roof, the atomic clocks that flew around the world in 1971, and the satellites correcting themselves by 38 microseconds a day are all busy confirming it as we speak. The third piece is the one that changes the subject entirely. The slowing of the clock is what a stationary observer sees. From inside the moving frame there is no slowing at all. The traveller's clock ticks perfectly normally, because it is not going anywhere from where the traveller sits. What changes instead is the world. The muon did not live longer. The mountain got shorter. The proton is not circling a 27-kilometre tunnel. It is circling a loop the length of a car. And the compression has no flaw written into it anywhere. Divide by gamma, and gamma has no upper limit. It is worth being honest about how much of your intuition has had to go, because we have been dismantling it gently and it is easy not to notice the pile. You believed that speeds add and they do not. There is a correction term, and at low speeds it is so tiny that centuries of careful experiment never saw it, and near light speed it is everything. You believed there was one present moment shared by everyone in the universe, and there is not. Two observers in relative motion slice the present at different angles, and there is no fact about which slice is correct. You believed that distance was a property of the world, and it is not. It is a property of the relationship between the world and whoever is measuring, and that relationship changes when you change velocity. Three foundational assumptions, all of them load-bearing for ordinary life, and all three are wrong in the same direction and for the same reason. So this is where we are. Speed does not stretch you. Speed compresses everything that is not you, along the direction you are facing, and the faster you go, the harder it compresses, and nothing in the equations ever says stop. Now I want to point at something we have walked past 3 times without naming it, because it is going to matter enormously at the end of tonight. Notice that every one of those effects is a trade. You do not get the compression for free, and you do not get it as a bonus. Every time distance gets shorter for the traveller, duration gets shorter by exactly the same factor. Every time the outside world says a clock is running slow, the clock says the outside world has become thin. The two numbers are never independent. They are the same number, appearing on opposite sides of the ledger, and they always balance to the last decimal place. There is a reason the trade has to balance, and it is worth stating because it removes any lingering suspicion that this is bookkeeping rather than physics. Two observers must always agree about what actually happened. They can disagree about how far apart two events were and about how much time separated them, but they cannot disagree about whether the muon hit the detector, or whether the two clocks read differently when they were placed side by side, or whether the proton completed its lap. Reality does not fork, so whatever the two observers do to their measurements, the operations have to compose in a way that always returns the same events at the end. And the only way to do that is for the distortion of distance and the distortion of duration to be locked to one another exactly. The balance is not a nice feature of the theory. It is the requirement that made the theory possible. That is not an accident, and it is not a coincidence, and a coincidence that precise usually means there is one thing underneath pretending to be two. And here is the other half of the observation, the one that has been sitting in plain sight since the first minute of this video. You have a rate too. Right now, lying still, having gone nowhere at all, you are moving through time at 1 second per second. You have never varied from it. You cannot vary from it, from where you are sitting. No matter what happens to you, no matter how fast you travel, your own watch will always agree with your own pulse, and your own second will always take exactly 1 second. We have been treating that as a triviality, as a tautology, even, of course, a second takes a second. What else could it take? I want to plant a flag on it instead, because it is not a tautology. It is a measurement. It is a rate, with a value, and the value is fixed, and every single thing in this video has been about what happens when you take some of that fixed rate and spend it somewhere else. Consider too what a peculiar thing it is that this rate is the one quantity nobody can ever catch changing. Everything else in the story is relative. Your speed is relative. It depends on who is watching. Your length is relative. The duration of your journey is relative. The order of two distant events can even be relative, and yet the rate at which you personally advance through your own life is absolutely fixed for absolutely everyone, in every state of motion, everywhere in the universe, forever. The traveller at 99% of light speed does not feel time crawling. The proton in the beam pipe does not feel 5 seconds stretched over a night shift. Every observer, without exception, experiences exactly 1 second per second. It is the single thing in relativity that nobody argues about. It has been hiding in plain sight this entire time, and I am not going to tell you yet what it means. But that is as far as I am going to take it for now, because we still cannot answer the question we started with. We know that clocks slow, we know that distances shorten, we know both by the same factor, and we know it is measured rather than argued. What we do not yet know is why any of that should end in the universe stopping. A distance divided by 7,000 is still a distance. A tunnel 3.5 meters long is still a tunnel. Nothing we have looked at so far has actually shut anything down. It has only made things smaller, and smaller is not stopped. To get from smaller to stopped, we have to do two more things. We have to go and look through the window of a ship that is actually moving at those speeds and see what the sky does, because it does something that no equation prepares you for, and it is the single most literal illustration of this video's title that physics has to offer. And then we have to find out why nobody, and nothing with mass, can ever finish that journey. The window first. Go outside on a clear night and the sky's all around you. That is such an obvious thing to say that it barely registers, but it is the specific feature we are about to lose, so notice it while you have it. Stars in front of you, stars behind you, stars over your left shoulder and down toward the horizon and directly overhead. You're standing at the center of a sphere of light, and every direction you turn has something in it. Now start moving, and keep moving, and watch what the sky does. At ordinary speeds, nothing. At the speed of the Earth around the Sun, 19 miles a second, there is an effect, and astronomers have known about it since 1729, when James Bradley discovered that stars appear to shift position by about 20 arc seconds over the course of a year because the Earth is moving sideways underneath their light. That shift is roughly 1/100th of the width of the full moon, and it took a century and a half of increasingly good telescopes to spot it. It is called aberration, and it is the same effect as tilting an umbrella forward when you walk through vertical rain. Now take that same effect and push it to 99% of the speed of light. The rain is not falling vertically anymore. It is coming almost horizontally, straight into your face, from a source that appears to be directly ahead of you no matter where it actually is. Light arriving from every direction, from the sides, from above, from behind you, gets swept forward into a cone in front of the ship, and the cone gets narrower the faster you go. The angular width of that cone scales roughly as 1 over gamma. At gamma of 10, the entire sky is compressed into a patch about 11 degrees across. At gamma of 100, it is about 1 degree, twice the width of the full moon as seen from your garden. At gamma of 1,000, the whole universe fits inside a spot 1/10 that size. Read that again, because it is not a figure of speech. Every star in the sky, every galaxy, the Milky Way behind you, the Andromeda galaxy off to one side, the 2 Magellanic clouds down in the southern sky, the cosmic microwave background filling every direction. All of it, the complete celestial sphere, gathered into a single bright disk directly in front of the ship, smaller than a coin held at arm's length. And behind you there is nothing. Not darkness in the ordinary sense, the sort of darkness that has stars in it. Actual emptiness. Whatever light is still managing to reach you from behind is stretched so far into the red and the infrared, and beyond that it stops being anything you could see. The colours in that forward disk do something equally strange. The Doppler effect runs alongside aberration, and everything you're flying toward is blue shifted. At moderate speeds, the stars ahead turn blue. Push harder, and they run through violet and out the other side into ultraviolet, and the light you're actually seeing at that point is not starlight at all. It is the infrared and the radio that was there all along, dragged up into the visible band. The disk develops structure, a hot bright core at the exact centre where the shift is strongest, and rings around it where the shift is weaker, each ring a different band of the spectrum. Science fiction used to call it the starbow. The real version is stranger and less pretty than the paintings, and it is calculable to as many decimal places as you like. Here is what I want you to sit with. The muon said, "I did not live longer, the mountain got shorter." The crew of that ship say something almost identical. We are not seeing the sky distorted. The sky got shorter. Because that is exactly what is happening. Aberration is not an optical illusion layered on top of the physics. It is length contraction and time dilation showing up in your eyes. The universe ahead of the ship has genuinely compressed along the direction of travel, and the light arriving from it is genuinely arriving from a narrower solid angle. And what the crew are looking at through that window is not a trick. It is the folded shape of the actual cosmos, as measured from where they are sitting. At 99.99% of light speed, gamma is about 70, and the whole visible universe is a bright patch 8 or 9 degrees across. At 99.9999%, it is under a degree. The faster you go, the smaller the universe gets, and the smaller it gets, the more of it is packed into that shrinking spot, until you are flying into a point of blue-white light that contains everything there is. And you have not gone anywhere yet. This is the view from the cockpit before the journey has properly begun. Come and stand at the forward port for a minute and look at it properly. The ship is quiet. There is no vibration, no sense of motion, no wind. There is nothing outside to make wind out of, and in any case you are not moving from where you stand. The floor is steady under you. The instruments say 99.9%, and they have been climbing all week, and the only way you know any of it is by looking out. Ahead of you there is a disk of light about the width of your fist held at arm's length, and it is the sky. Not part of the sky. The sky. Somewhere in that disk is the star you left, and somewhere in it is the star you're going to, and somewhere in it is every star anyone on your planet ever named, and they are packed so tightly together now that constellations have stopped meaning anything. The centre of the disk is a hard blue-white, so bright it is uncomfortable to look at directly. Further out it runs to violet, and then the rim shades into a colour you cannot see at all, a ring of ultraviolet that the hull sensors report and your eyes do not. You put your hand up and cover it, all of it, the entire observable universe, gone behind 4 fingers. Then you walk to the back of the ship and look out of the aft port, and there is nothing there. No stars, no glow, no faint background. Dark red running into black, running into an absence that does not even feel like a direction anymore. Everything that exists is in front of you now, and the longer the engines run, the smaller it gets. Now think about what that does to the ordinary experience of travelling. When you drive somewhere, the world comes past you. Things enter your field of view from ahead, grow, pass on either side, and recede behind. That sequence is what travelling feels like, and it is the reason a long drive feels long. On a relativistic ship, that sequence does not happen. Nothing passes you on either side because there is no longer any such thing as either side. Every object in the universe is ahead of you, arriving out of the same shrinking disk, until the moment it is behind you and gone. There is no landscape. There is no scenery going by. There is a bright point in front and a dark nothing behind, and the point does not appear to get closer, because the thing you are aiming at is inside it along with everything else. The universe has stopped being a place you move through, and become a thing you are pointed at. There is one more piece of this that deserves its own moment, because it is the detail that convinces people the effect is real, rather than a graphics trick. Stars that are genuinely behind the ship appear in front of it. Not near the edge of your vision, not off to the side. In front, inside the forward disk, mixed in with the stars you're actually flying toward. A relativistic traveller looking dead ahead is looking at objects she has already passed. There is no direction she could turn to see them where they really are, because from her frame that is where they really are. The geometry of the sky is not something the universe hands out once and for all. It is assembled fresh for every observer out of the light that is currently arriving, and if you change how you are moving, you change what arrives, and the sky rearranges itself accordingly. There is also a subtlety here that trips up nearly every illustration of this you will ever see. What we have just described is what the crew would see, and seeing is not the same as measuring. Remember the Terrell-Penrose result. Because light from different parts of an object leaves at different moments, images of relativistic scenes are assembled out of time slices that do not belong together, which is why a passing object photographs as rotated rather than flattened. The same caveat applies to the sky. The compressed forward disk is a genuine feature of what arrives at the ship's window, and untangling exactly which part of it is contraction, which part is aberration, and which part is the finite travel time of the light itself takes real care. The physicists who make those simulations spend most of their effort on precisely that separation. The headline survives it. From a fast enough ship, the universe is a spot ahead of you. Notice how much of the title we have now assembled without ever using an infinity. At gamma of 1,000, a perfectly finite number that a perfectly finite particle can reach. The sky's a dot, the distance ahead is divided by 1,000, and the duration of the trip is divided by 1,000. Nothing has broken. No equation has divided by 0. And already there is almost no universe left to be in. Push gamma to 1,000,000, and the dot is 1,000,000th of the size, and the distance to Andromeda is 2.5 light-years rather than 2.5 million, and the crossing takes about 2.5 years of ship time instead of 2.5 million years. Push it further and the trend does not bend or level off or hit some hidden resistance. It goes exactly where you think it goes. Which raises the obvious question, and it is the question that occupies the next part. If the trend just keeps going, and nothing in the mathematics objects, then what actually stops a ship from riding it all the way down to 0? Because something does. The universe has been perfectly willing to fold, and it turns out to be extremely unwilling to close. There is roughly 1 hydrogen atom in every cubic centimetre of interstellar space. 1, in a volume about the size of a sugar cube. That is the emptiest environment most people can imagine, and it is a better vacuum than anything we can manufacture on Earth outside of a few specialised laboratories. When people say space is empty, that number is what they mean. At 99% of the speed of light, that same number means something entirely different. It means you are flying into a particle beam. Work it through. Gamma at 99% is 7.09. A hydrogen atom sitting still in the interstellar medium has a rest energy of about 938 million electron volts. In the ship's frame, that atom is not sitting still. It is coming at you at 99% of light speed, and it arrives carrying about 5.7 billion electron volts of kinetic energy. 5.7 billion electron volts is roughly what a proton carries in the Large Hadron Collider beam, not a fraction of it, the same order of magnitude. So here is the situation. A ship with 100 square meters of frontal area, moving at 99% of light speed, sweeps up somewhere around 30,000 trillion of those atoms every second, each one arriving with collider energy. That works out to something like tens of megawatts of hard radiation pouring continuously into the forward structure of the ship, not as heat you could radiate away, but as high-energy particles that penetrate far into whatever they hit, break apart nuclei inside the hull material, and produce showers of secondaries on the far side. Interstellar space is not empty enough. At relativistic speed, it is a beamline and you are the target. Dust makes it worse in a way that is easier to picture. The interstellar medium is not purely hydrogen. There are grains in it, most of them a fraction of a micrometer across, which is to say far smaller than anything you could see. At ordinary speeds, a grain like that is nothing. Spacecraft have been running into them for decades without incident. At 99.9999% of light speed, a single grain a few micrometers across arrives carrying roughly the energy of an artillery shell. 1 grain. And there are a great many grains, and no way to see them coming, and no time to move if you could. The engineering response to this is not a shield in the ordinary sense. Freeman Dyson worked through the problem decades ago, and concluded that the dominant design constraint on any relativistic ship is not the engine at all. It is the forward barrier, which has to be enormous, thick, sacrificial, and flown far ahead of the crew so that the shower of secondaries has room to spend itself before reaching anything alive. Robert Bussard proposed in 1960 to turn the problem into a solution, scooping the interstellar hydrogen with an enormous magnetic field and burning it as fuel, the interstellar ramjet, one of the most beautiful ideas in the history of spaceflight. Later analysis by Robert Zubrin and Dana Andrews showed that the scoop would produce more drag than thrust. The idea does not work. It is still beautiful. And the hydrogen is the small problem. Fill space with nothing at all. Remove every atom, every dust grain, every stray particle, and you still cannot escape the light. The cosmic microwave background is the cooled remnant of the Big Bang, and it fills every cubic centimetre of the universe uniformly at a temperature of 2.725 Kelvin. It is microwave radiation. It is, at rest, about the gentlest thing in existence. It would take an unimaginable length of time to warm anything by a measurable amount. Fly into it fast and the Doppler shift goes to work. The forward blue shift factor is roughly twice gamma. At gamma of 100, the microwave background ahead of the ship is no longer microwaves. It is a bath at several hundred Kelvin, hotter than an oven. At gamma in the low thousands, it is ultraviolet. At gamma of 1,000,000, the residual warmth of the early universe has been shifted all the way into gamma rays, and the ship is flying into a sleet of ionizing radiation generated by nothing at all, by the empty background of the cosmos, made lethal purely by the act of approaching it quickly. This is not a speculative hazard invented for a video. It is the reason the highest energy cosmic rays cannot travel far. Above about 5 times 10 to the 19th electron volts, a proton moving through intergalactic space sees the microwave background as a gale of gamma rays energetic enough to knock pieces off it. Every collision strips away energy. The effect is called the Grayson-Zatsepin-Kuzmin cutoff, after the 3 physicists who independently worked it out in 1966, and it means that any particle above that energy must have been launched somewhere within roughly 160 million light-years of us, because anything travelling further would have been ground down before it arrived. The universe polices its own speed limit with its own leftover heat. It is worth noticing that this is one of the very few places in physics where the difficulty of a journey does not come from the distance. Everything about a relativistic trip gets easier as you go faster. The gap shrinks, the crossing time shrinks, the years aboard shrink. Everything except the environment, which gets more hostile in exact proportion to how much easier the geometry becomes. The same gamma factor that folds the universe conveniently in front of you is the factor that turns its residual warmth into a weapon. You cannot have one without the other, because they are the same number, and this is the first genuine sign that the universe is not merely being difficult about light speed, it is defending it. And even if you solved all of that, a perfect shield, a perfect scoop, a hull that laughs at gamma rays, you would run into the wall that no engineering touches. The kinetic energy required to accelerate a mass to a given speed is gamma minus 1, times the mass, times the speed of light squared. Look at what that does. To get 1 kilogram to 99% of light speed, gamma is 7.09, so you need about 6 times its rest energy, roughly 5.5 times 10 to the 17th joules. That is around 130 megatons of TNT per kilogram one way, with no deceleration and at 100% efficiency, which is not a thing that exists. Scale that to a modest ship. 1,000 tons at 99% of light speed needs on the order of 10 to the 21st joules. Global human energy consumption is around 6 times 10 to the 20th joules per year, so a single one-way trip at perfect efficiency costs everything our entire civilization produces for a couple of years, and a real ship needs to slow down at the other end, which roughly squares the fuel requirement, and no engine is perfectly efficient, and the exhaust of the only engine efficient enough to be worth discussing is a flood of lethal gamma radiation. But none of those are the actual wall. Those are all large numbers, and large numbers are the sort of thing engineering exists to defeat. The wall is what happens at 100%. Gamma is 1 over the square root of 1 minus v squared over c squared. Put v equal to c, and the bracket becomes 0, and the square root of 0 is 0, and 1 divided by 0 is not a large number. The energy required to bring anything with mass to exactly the speed of light is not enormous. It is infinite. Not more energy than exists. Not more than we could ever build. Infinite, meaning there is no finite quantity of anything, anywhere, ever, that completes the job. A universe 1 trillion times larger than ours, converted entirely into fuel, gets you closer to the line and does not reach it. Every joule you spend buys you another 9 after the decimal point, and there are always more 9s. There is a way of stating the infinity that makes it feel less like a formula and more like a fact about the world. Suppose you have a spacecraft with a perfect engine and an unlimited supply of fuel, and you simply leave it running. Forever. You will accelerate forever. Your speed will climb, 9 by 9, and you will never once experience a moment where the engine loses effectiveness, or the ship feels heavy, or something obviously physical intervenes to stop you. From inside, nothing resists you at all. What you will find, if you keep checking, is that no matter how long you have been burning, there is exactly as much of the gap left as there was before. Because the gap is not measured in speed. It is measured in energy, and the energy needed to close it does not decrease as you approach. That is a different kind of prohibition from anything else in engineering. A bridge that is too heavy can be redesigned. A material that is too weak can be replaced. This is a statement that the destination is not at the end of the road, because the road does not have an end. So we have found the reason no ship ever arrives. What we still have not found is what would be there if it did. And there is one object in the record that got closer than anything we will ever build, and it did it without an engine, and nobody has any idea what launched it. In the Utah desert, about 80 miles southwest of Salt Lake City, there is a stretch of army land called Dugway Proving Ground. It is flat, it is dry, and on a moonless night it is one of the darkest places in the continental United States. In 1981, physicists from the University of Utah installed something there called the Fly's Eye. 67 large mirrors, each one about 1.5 meters across, pointed up at different patches of the sky, each fitted with a cluster of photomultiplier tubes. The Fly's Eye is not a telescope. It does not look at stars. It watches for a faint flicker of ultraviolet light in the air itself, which is what happens when something enormous hits the top of the atmosphere and starts a cascade. On the night of the 15th of October, 1991, it caught one. The flash was bright. It was so bright that the team spent a long time afterwards looking for an instrument fault because the energy it implied was not supposed to be possible. When they had checked everything and found nothing wrong, the number stood 3.2 times 10 to the 20th electron volts in a single subatomic particle, almost certainly a proton. Numbers that large stop meaning anything, so here is the translation. 3.2 times 10 to the 20th electron volts is about 51 joules. That is the kinetic energy of a baseball thrown at around 60 miles an hour, or a cricket ball off a fast bowler, the sort of impact that stings your hand through a glove. All of it, packed into one particle about a quadrillionth of a meter across. It is roughly 40 million times more energy than the Large Hadron Collider can give a proton. 40 million. The Fly's Eye itself was retired in 1993, 2 years after its most famous night, and was succeeded first by an instrument called HIRES, and then by the telescope array. None of them has ever seen anything bigger. They called it the Oh My God particle, and 35 years later it is still the highest energy cosmic ray ever recorded. There is a comparison that physicists reach for to make the speed itself concrete, and it is the best one I know. Put that particle in a race against a beam of light, running side by side for 1 full year. At the end of the year the light is ahead, but only by a distance smaller than the width of a human hair. 365 days of running, across roughly 6 trillion miles, and the gap between them is less than a millimeter. That is what 99.99 and 20 more nines actually looks like when you stretch it out over a year. Now do to it what we have been doing all night. Do not ask how fast it was going in our terms. The answer is a tedious string of nines, 99.99, and then 20 more nines, and then a 5-1. Ask what gamma was. Gamma for that particle was about 340 billion. Take that number and put it into everything we have built tonight. The Milky Way is 100,000 light-years across. Divide by 340 billion, and from that particle's own frame, our entire galaxy, the whole disk, the spiral arms, the bulge, all 400 billion stars, is a sheet about 9 light-seconds thick. Less than the distance from the Earth to Saturn. It crossed the galaxy in about 10 seconds of its own time. Go further. The observable universe is roughly 93 billion light-years across. From that particle's frame it measures about 100 light days. Everything there is, edge to edge, in about 3 months. That is the closest anything we have ever detected has come to the thing this video is about. Not a ship, not an experiment, not a thought experiment. An ordinary proton, launched by something we cannot identify, that spent its existence looking at a universe folded down to almost nothing. Stand in the desert with it for a moment. It is somewhere after midnight and cold, and the 67 mirrors are all staring upward at a sky with no moon in it, and the electronics are humming, and for most of any given night nothing happens that anyone would call remarkable. Then a faint blue-violet streak crosses one patch of sky, lasting about 30 microseconds, and the tubes register it, and a number is written down that will occupy people for the next 3 decades. It is also worth understanding what the Fly's Eye was actually detecting, because the mechanism is lovely. A single primary particle of that energy never reaches the ground. It hits a nucleus in the upper atmosphere and shatters, and the fragments hit other nuclei and shatter, and within a few kilometers the one particle has become a cascade of billions of secondaries spreading out over a footprint several kilometers wide. As that cascade passes through the air it excites nitrogen molecules, which glow faintly in the ultraviolet as they settle. The fly's eye did not catch the particle. It watched the sky itself fluoresce along the path where the particle had been, the way a wake tells you a boat went by. Now turn the camera around and be the particle. You were launched somewhere, nobody knows where, and that is not a figure of speech, it is the actual state of the field. Whatever accelerated you is not in our galaxy, because nothing in our galaxy has the power, and it should not be much outside our galaxy either, because the microwave background would have ground you down over any longer journey. There is nothing obvious in the direction you came from. From your side, the trip took very little time and covered very little distance, because from your side the universe was a sheet you passed through. Then thin gas, then thicker gas, then a wall of atmosphere, then a shower of secondaries fanning out across kilometers of Utah, then a flicker of light in the air, then nothing. And here is the part that stays with me. We could not build that. Not with all of our energy, not with a machine the size of the solar system, not at any scale we can seriously discuss. Something out there did it casually, in the ordinary course of business, and has presumably been doing it for billions of years, and we do not know what it is. The mystery of where it came from is not a small footnote either, and it has only deepened with time. The Greisen-Zatsepin-Kuzmin cutoff we met in the last part says that a proton above about 5 times 10 to the 19th electron volts cannot survive a journey longer than roughly 160 million light-years, because the microwave background wears it down, so the source has to be relatively nearby in cosmic terms. But the particle carries far more energy than any nearby object we know of can produce, and its arrival direction points at a patch of sky where there is nothing that fits. Active galactic nuclei, gamma-ray bursts, magnetars, colliding galaxy clusters. Every candidate that has been proposed has a problem, either of power or of location. The field has been arguing about it since the year it arrived. There is a second one for what it is worth. On the 27th of May, 2021, the telescope array, the fly's eye's much larger successor, spread over 700 square kilometers of the same Utah desert, recorded a particle at about 2.4 times 10 to the 20th electron volts. It was announced in 2023 and named Amaterasu, after the sun goddess of Japanese mythology. Like its predecessor, it arrived from a direction where there is essentially nothing to have produced it. So nature runs this experiment regularly. It has been running it since long before there was anyone here to notice, and it will keep running it after we're gone, and every one of those particles is a passenger who saw the folded version of the universe we will never see. And there is a quieter reason this matters for tonight's question. Everything else we have looked at has been us doing something to a particle, accelerating it, timing it, steering it around a tunnel we built. This one was not ours. Nobody set it up, nobody funded it, nobody chose the parameters. Somewhere out there the universe casually produced a state of motion we cannot approach, and the only reason we know is that it happened to land on a patch of desert where 67 mirrors were watching. But notice something about all of them. Not one has arrived. Not one of them is at the speed of light. Every one of those particles at gamma of 340 billion is still going slower than light, still has a finite journey, still experiences some duration, however small. They have crowded up against the line and not one has touched it. Which leaves the honest question hanging exactly where it has been hanging since part 1. What would it actually be like at the line? Before we can answer that, it is worth asking what the journey would cost a person, because unlike a proton, we would have to bring a life along. Set aside the fuel problem for a few minutes. Set aside the shielding and the microwave gale and the 130 megatons per kilogram. Imagine somebody solves all of it, and you have a ship that can hold a steady acceleration of 1 gravity, 1 g, the same pull you feel sitting where you are sitting, for as long as you like. That specification is not arbitrary. 1 g is the acceleration that makes a spacecraft feel like a building. The floor is the wall the engine pushes against, so you would walk around normally, pour a glass of water normally, sleep in a bed. It is also, conveniently, the acceleration at which Relativity's arithmetic comes out unnervingly clean, because the speed of light divided by 1 g is about 0.97 light-years, which is close enough to 1 that a light-year is very nearly a year of comfortable acceleration. So switch the engine on and leave it on. After 1 year of ship time, you are travelling at about 77% of light speed. After 2 years, 97%. After 3, 99.5. The engine never stops working and you never arrive at light speed, but gamma climbs, slowly at first, then not slowly at all. and as it climbs, the universe in front of you does exactly what we watched it do in Part 8. It folds. It is worth pausing on what the trip would actually be like day to day, because the answer is much stranger than the numbers suggest and much more ordinary. Nothing aboard would feel fast. The engine would be a low, steady note somewhere under the floor. The gravity would be constant. The lights would be on. And out of the window, week by week, the sky would tighten. The constellations gathering forward, the colours sliding blue, the aft view emptying out, until at some point in the second year somebody would look up and realise that the entire universe now fitted comfortably inside the forward port, and that there was no longer any such thing as a view to the side. Then they would go and have dinner, because it would have happened gradually, and human beings normalise almost anything that happens gradually. And because it folds, the arithmetic of interstellar travel becomes something almost gentle. Here is what a 1G ship gets you, accelerating for the first half of the trip and decelerating for the second, so that you arrive at rest rather than tearing through your destination at 99.9% of light speed. Proxima Centauri, 4.24 light-years away, the nearest star to our own, about 3.6 years of ship time, roughly 6 years pass on Earth. Sirius, 8.6 light-years, about 4.7 years aboard. The Pleiades, the little cluster you can see with your own eyes on a winter night, about 440 light-years away, about 12 years aboard. 442 on Earth. The centre of the Milky Way, 27,000 light-years, past the dust lanes and into the crowded core where the stars are packed thousands of times more densely than they are here, about 20 years aboard. The Andromeda Galaxy, 2.5 million light-years, about 28 years of ship time, and the edge of the observable universe, 46 billion light-years away, somewhere on the order of 45 years, one working life. You could be 22 when you leave and 67 when you reach the far boundary of everything we can see. Look at that list again and notice what is happening to it. The distance goes up by a factor of 10 billion between the first entry and the last. The travel time goes up by a factor of 12. That is not a rounding error in my arithmetic. It is the actual shape of the relativistic rocket equation, where the trip time grows only logarithmically with distance, because the further you're going, the faster you get, and the faster you get, the shorter the trip becomes. Every doubling of distance adds roughly the same fixed amount to the journey, and that fixed amount is small. There is a subtlety in these numbers that is worth naming, because it is where most people's intuition rebels. You might reasonably object that nothing can travel faster than light, so how can a ship cross 2.5 million light-years in 28 years without breaking the rule? It does not break the rule. In Earth's frame, the ship never exceeds light speed, and the crossing genuinely takes 2.5 million years. In the ship's frame, the ship is not moving at all and Andromeda is coming toward it, and the distance to Andromeda measured from the ship is not 2.5 million light-years. At the speeds involved, it is only a few dozen. The crew do not cover the distance quickly. They cover a much shorter distance at an ordinary relativistic pace. Nobody breaks anything. The universe simply hands them a shorter version of itself. So the honest position is this. There is no distance in the observable universe that a human being could not cross within a human lifetime, given an engine we do not have. The universe is not too big. It was never too big. It only looks too big from the flat end of the curve, where we live. Now read the other column. Andromeda in 28 years aboard, and 2.5 million years at home. Sit with the shape of that. A crew stands up from a launch on an ordinary morning. They spend 28 years living an ordinary life. Meals, arguments, birthdays, somebody learning to play an instrument badly, 2 people falling in love and one of them regretting it. The slow accumulation of a shared history in a metal room. They step out at the other end still young enough to work, and behind them, the people who came to see them off have been dead for 2.5 million years. Not their children. Their children died 2.5 million years ago too. Their language is gone. Their species has changed into something else or into nothing. The constellations they grew up naming have dissolved, because 2.5 million years is long enough for the stars to have drifted out of their patterns. Even the 2 galaxies have moved. The Milky Way and Andromeda are falling toward each other at about 110 kilometers a second, and a crew making that crossing would arrive to find the merger already beginning behind them. The physics does not forbid the journey, it only forbids the return, and it is not a matter of engineering a faster ship for the trip home. There is no faster ship. The asymmetry is not in the vehicle, it is in the structure of space-time. You can spend your motion getting there, or you can spend it staying present with the people you left, and you cannot do both, and no technology in any possible universe changes that, because it is not a technology problem. I think this is the real weight of the speed of light, and it is almost never where people put it. We talk about the light barrier as though it were a fence around the cosmos keeping us penned in. It is not. The cosmos is wide open. The folding sees to that. What the speed of light fences off is not distance. It is the present moment. You can go anywhere at all, and the price is that you cannot take now with you. We should be honest that no serious proposal comes anywhere near this. The breakthrough starshot concept, which is the most credible relativistic mission anybody has costed, aims to push a sail weighing a few grams to about 20% of light speed using a ground-based laser array. At 20%, gamma is 1.02. The universe contracts by 2%. Nothing in this part of the video applies to it at all, and that is deliberate. The designers chose a speed regime specifically below the point where any of the hard problems begin. There is a version of this that is already happening, at a scale so small it is almost a joke and is not a joke at all. Sergei Krikalev, the Russian cosmonaut, spent about 803 days in orbit across 6 space flights. Moving at roughly 7.7 kilometers a second, he accumulated a time difference of about 1/50th of a second relative to everyone on the ground. He holds the human record for travelling into the future, and the record is 20 milliseconds. Scott Kelly, after 340 days on the International Space Station, came back a few milliseconds younger than his identical twin brother Mark, who is the same person genetically, and is now, permanently and unarguably, very slightly older. 20 milliseconds is nothing, and it is the same effect on the same curve obeying the same equation as the 28 years that cost $2.5 million. Which brings us finally to the line itself. Everything so far has been about approaching. We have watched the sky close, watched the distances divide, watched the energy bill run to infinity, and watched a particle get within 22 decimal places of the answer without touching it. So let us walk right up to it and ask the question directly. What happens at exactly the speed of light? The answer is not what anybody expects, and it is not a description of a place. Take the equation and put the number in. Gamma is 1 divided by the square root of 1 minus v squared over c squared. Set v equal to c, then v squared over c squared is 1, and 1 minus 1 is 0, and the square root of 0 is 0, and you are dividing 1 by 0. Now go and find the formula for how much time passes for the traveller. It is the elapsed time in the outside world divided by gamma. Divide anything by infinity and you get 0, so the answer is that no time passes. And go and find the formula for how far the traveller has travelled in their own frame. It is the outside distance divided by gamma. 0 again, no distance either. And that is where nearly every explanation of this subject stops, with a satisfying flourish. At the speed of light, no time passes and no distance is covered. It sounds like an answer. It is not one, and the reason it is not one is the strangest thing in this entire video. Work it through properly, and you do not get 0. You get 0 divided by 0. The elapsed time is the outside time divided by an infinite gamma, and the outside time for a journey at exactly light speed is itself unbounded, and the distance is an unbounded distance divided by an unbounded factor. Every quantity you would need to describe the trip has become the ratio of 2 things that have both run away to infinity, and in mathematics that is not a small number or a large number. It is not a number at all. It is the signature of a question that has not been properly asked. And the reason it has not been properly asked is structural, not arithmetical. Relativity works by letting you convert one observer's measurements into another's, using the Lorentz transformations. Those transformations form what mathematicians call a group, a complete closed set of allowed conversions. You can convert to the frame of a ship at half light speed, or 99%, or 99.9999999%. You can convert to the frame of the oh my god particle at gamma of 340 billion. What you cannot do, at all, ever, is convert to a frame moving at exactly c, because no such element exists in the group. There is no coordinate system in which a photon is at rest. It is worth saying plainly that this is not a loophole or a technicality that a cleverer theory would clean up. It is the same structure that shows up everywhere the invariance of light speed does. A photon has no rest frame for exactly the same reason it has no rest mass, and exactly the same reason it always moves at c for everybody. Those 3 statements are one statement, viewed from 3 angles, You cannot fix one of them without demolishing the other two, and the other two are the most heavily tested claims in physics. Read that as a statement about the world and not about the equations. There is no such thing as the point of view of a light beam. Not, we don't know what it's like. There is no it. Physics does not decline to answer the question out of modesty or ignorance. It reports that the phrase describes no possible situation, the way the largest whole number describes no possible number, which means the question I asked in part 1, the one I promised to answer tonight, has a shape most people never notice. If you ask what the universe looks like from a ship at light speed, the honest first move is to point out that there is no ship. Any object with mass that is travelling at sea has stopped being an object with mass because its energy would be infinite. The only things that go at sea are things with no rest mass at all, and they do not carry passengers, and they do not have windows. So here is where we stand at the end of the approach. The universe genuinely folds. That is measured. The folding genuinely has no flaw in the equations. That is also solid. And the destination, the state of actually being at light speed, is not a place you fail to reach for practical reasons. It is not a place. Now, before we go to the answer, there is one experiment that everyone brings up at this point, and it deserves a straight response because the real result is extraordinary, and the conclusions people draw from it are wrong. In 1999, a team led by Lin Hao, working at Harvard and the Roland Institute, published a paper in Nature reporting that they had slowed a pulse of light to about 17 meters per second. 17 meters per second is 38 miles an hour. It is slower than a cyclist on a good day. Light, which crosses the gap between here and the moon in a second and a quarter, was moving at roughly 17 million times less than its usual pace, and you could in principle have jogged alongside it. The technique is beautiful. They cooled a cloud of sodium atoms to within a fraction of a degree of absolute zero into a Bose-Einstein condensate, a state where the atoms lose their individual identities and behave as a single quantum object. Then they used a second laser to make that cloud transparent at a wavelength where it would normally be completely opaque, a trick called electromagnetically induced transparency. The result is a medium with an extraordinarily steep relationship between wavelength and refractive index, and a light pulse crawling through it. 2 years later, in 2001, the same group did better. They stopped the pulse entirely. They brought a beam of light to a complete halt inside the condensate, held it there, and then released it and let it continue on its way, carrying the information it had been carrying when it went in. This is real. It is published, replicated, and it is the ancestor of serious current work on quantum memory. And here is the claim that circulates about it, which you will find in 100 videos and 1,000 comment threads. If light experiences no time, and we can slow light down to walking pace, then we can match its speed, step into its timeless condition, and open a gate through space and time. That does not follow, and the reason is precise. Nothing in that experiment slows a photon down. What travels through the condensate at 17 meters per second is not light. It is a hybrid, a coherent mixture of the light field and the atomic excitations it creates, which physicists call a polariton. The pulse's energy is repeatedly absorbed by atoms and re-emitted, and the delay comes from the time spent in the atoms. Between interactions, every individual photon is moving at exactly c, as it always does and always must. When Hao's team stopped the light, what they actually did was park all of the information in the atomic medium, with no photons left travelling at all, and then hand it back. You cannot ride a polariton to anywhere. There is no timeless state sitting in that glass cell waiting for someone to step into it. The experiment is one of the finest pieces of atomic physics of the last 30 years, and it has nothing whatsoever to do with travel. While we are clearing ground, there is a second objection worth answering, because it is the one thoughtful people raise, and it deserves better than dismissal. It goes, perhaps time dilation is not about time at all. Perhaps motion simply stresses the mechanisms of clocks and makes them tick badly, and what we are measuring is an instrumentation artifact dressed up as metaphysics. The answer is that every possible clock is affected identically. Muon decay is a nuclear process. Cesium clocks are atomic. Optical clocks are electronic. A pendulum is mechanical. A heartbeat is chemical. The rate at which a person ages is biological. Every one of them slows by exactly the same factor, at exactly the same speed, and no experiment has ever found a process that keeps a different beat. If every conceivable measure of duration agrees, There is no leftover process to appoint as the true clock, and the distinction between time slowed and everything that could measure time slowed quietly stops carrying any meaning at all. There is a third claim that circulates, and it is worth about a minute, because the physics inside it is real even though the conclusion is not. The claim is that because a light ray traces what is called a null path, an interval of exactly zero between the moment it is emitted and the moment it is absorbed, the universe must therefore be a hologram, or a projection, or a simulation. The first half of that is correct and quite beautiful. Along the path of a light ray, the space-time interval genuinely is zero, which is a real and fundamental statement about the geometry of the world. The holographic principle is also a serious idea, arising from the discovery that the information content of a black hole scales with its surface area rather than its volume, and it may well turn out to be true. But the one does not imply the other, and neither of them implies that anything is being computed. This is a case of a genuine and elegant piece of physics being recruited into a conclusion it does not support, which is a much more common failure mode than outright invention. It is worth noticing how much company you're in if the two observers problem still bothers you. Herbert Dingle was a respected British physicist and a former president of the Royal Astronomical Society, and he spent the last 2 decades of his life publicly arguing that the twin paradox proved relativity self-contradictory. He wrote a book about it. He never accepted the resolution. That is not a reason to doubt the physics. The physics is fine, and the resolution is the asymmetry of the paths. But it is a good reason to be gentle with yourself if this is the part your intuition keeps refusing. It has trapped professionals, so the ground is clear. There is no gate, no artifact, and no frame. We have followed the folding as far as it will go and arrived at the edge of a description that does not extend any further. And now, at last, we can answer the question. Put your hand flat on whatever is nearest to you. The mattress, the arm of the chair, the wall. It is holding still. It has been holding still all night while we have been taking the universe apart, and it is going to keep holding still, and I want you to keep touching it while I tell you the answer, because the answer is about you and not about the ship. Here is the mechanical version first, plainly, with nothing withheld. As your speed approaches the speed of light, 2 things happen to the universe in front of you, and they happen at exactly the same rate. Every distance along your direction of travel is divided by gamma, and the duration of your crossing, the amount of your own life the journey consumes, is divided by gamma as well, not one and then the other, together, locked, by the same factor, always. Now push gamma up. At 7, the 4 light years to the nearest star becomes 7 months of light travel, and the trip costs you 7 months. At 70, it is 3 weeks. At 7,000, the distance is a few hours and the trip is a few hours. At 340 billion, the oh my god particles number, the entire Milky Way is 9 light seconds thick and takes 10 seconds to cross. Keep going. The distance ahead of you shrinks towards 0. The time it takes shrinks towards 0. And when both of them arrive at 0 together, the place you are leaving and the place you are going are not 2 places anymore. There is no gap between them, and there is no interval between departure and arrival, and therefore there is nothing in between for anything to happen in. That is what it means for the universe to stop. It does not slow down, wind down, or freeze the way a film freezes on a frame. It collapses. Every distance you were going to cross becomes no distance, and every moment that was going to pass while you crossed it becomes no moment, and the entire cosmos in the direction you are facing is compressed into a single point at a single instant that you are already standing in. The Muon said it first, in the simplest possible form, back in part 5. Nothing happened to me. The mountain got shorter. That is the whole thing, taken to the end of the line. The mountain got shorter, and the atmosphere got shorter, and the tunnel under Geneva got shorter, and the sky in the forward port got shorter, and the 4 light years to Proxima got shorter, and the 2.5 million to Andromeda got shorter. Everything got shorter, and at the speed of light, everything gets shorter all the way to 0, which is the same sentence as the universe stops, just written in the language of rulers instead of clocks. So that is the answer to the title, and if that were all, it would be enough. It is not all, and the layer underneath is the reason I made you wait. Because you might reasonably ask, why should there be a trade at all? Why should going faster through space cost you anything in time? Those 2 things have nothing obviously to do with one another. You can walk across a room without your watch caring. The relationship seems arbitrary. a strange fee levied by a strange universe for reasons nobody explained. It is not arbitrary. Here is what is actually going on, and it is the single most beautiful idea in this subject. Everything in the universe is moving at exactly the speed of light, all the time, right now, without exception, not through space, through space-time. Every object that exists has a fixed total rate of motion through the four-dimensional structure of reality, and that rate is the same for every object, and its value is c. What you get to choose, what your engines and your legs and the orbit of your planet get to choose, is how that fixed total is divided between the three directions of space and the one direction of time. Sit perfectly still, and you're spending none of it on space, which means all of it is going into time. You're moving through time at the full allowance, the maximum rate anything is permitted, and there is a phrase for that rate that you have been carrying since the first minute of tonight: 1 second per second. That is not a tautology. It never was. It is a measurement, and the value it reports is light speed, straight down the time axis at full throttle, and you have been holding it your entire life without ever once feeling it. Now start moving. Every bit of speed you take through space has to come out of somewhere, and the only place it can come from is the budget you are spending on time. So your motion through time drops. Your clock runs slow, not because it is broken, not because something is squeezing it, but because you have diverted part of its allowance into crossing a room. Go faster, and you divert more. Go at 99% of light speed, and you have taken almost the whole budget and pointed it sideways, and there is almost nothing left with which to move forward through time. And at the speed of a light, you would have taken all of it. Every bit of your motion would be going into space. None of it, not a fraction, would be left over for time. That is the answer underneath the answer. The universe does not stop. You stop moving through it. And here is the part that makes the title honest rather than merely dramatic. From where you are sitting, there is no difference between those two statements. If your motion through time has gone to zero, then nothing outside you can advance. Because advancing is something that happens in time and you're no longer spending anything there. You have not paused the universe. You have withdrawn from the only dimension in which the universe does anything. From the inside, the two look identical, and the inside is the only place you will ever be standing. So there was never a stage. Do you remember it? From part 1, the floor with fixed distances marked on it, the clock hung overhead for everybody. It was a good picture and it worked for 400 years, and it is not what is out there. There is no fixed floor because distance is not a property of the universe. It is a property of the relationship between the universe and whoever is measuring it. There is no clock overhead because there is no shared present moment for it to keep. What is out there is one four-dimensional structure, and every one of us is cutting a different slice through it at a different angle, and what we call space and what we call time are just the two halves of the cut. And now, I want to give you the thing I've been holding since the beginning. You're travelling at the speed of a light right now, not metaphorically. Lying there, having gone nowhere, having moved perhaps a few centimetres in the last minute, you are moving through space-time at exactly c, and because essentially none of it is going into motion through space, essentially all of it is going into time. You are running the time axis at maximum. Every second you have ever experienced, every moment of your life that has arrived on schedule, every next breath that has shown up when it was supposed to, has arrived at that rate because you are spending your full allowance on getting there. The reason you have a next moment at all is that you are not spending your motion on distance. That is what the ship gives up. Not comfort, not safety, not the people it leaves behind. Those are consequences. What it gives up is the thing you have right now for free, which is the ordinary unremarkable arrival of the next instant. A traveller at the limit does not get a frozen universe as a prize. They get no universe, because there is nothing left to spend on being present in it. The reason light can cross 13 billion years of space and arrive unchanged is that from its own side there was nothing to cross and no time in which to change. It does not experience the journey. It does not experience anything. That is the price of the maximum speed, and it is paid in full. And so the universe stops when you travel at light speed. And the reason is not that time breaks, or that physics fails, or that something out there slams shut. It stops because you have taken every last piece of your motion out of time and spent it on space, and a universe you're not moving through in time is a universe in which nothing can happen to you. I will leave you with the honest part because there always is one. Nobody knows why the universe insists on the trade. Relativity describes it perfectly, to more decimal places than we know what to do with, in satellites and colliders and mountaintop muon counters, and it does not explain it. The constancy of the speed of light is a postulate. It is an experimental fact we agreed to build on because everything built on it works. There is no deeper theory that derives it, and a universe with no speed limit at all is perfectly coherent. It is Newton's universe, with instantaneous causes, absolute simultaneity, a real shared present moment, and no relativity of any kind. That universe would have worked. Ours is not it, and no one can tell you why. And there is a second thing nobody knows, which is what any of this does at the very bottom. The contraction has no flaw in the equations. Divide by gamma, and gamma runs forever. But if space-time is granular at the smallest scales, somewhere down around 10 to the minus 35 meters, then a contracted length cannot fall below the smallest length there is, and something has to give that we have never seen give. Physicists have proposed modifications. None of them has been tested because we have no way to get there. So we are left with something quite lovely in the end. We can tell you exactly how the universe folds in front of a traveller, and we can measure it with a wardrobe-sized counter on a cold mountain in New Hampshire, and we cannot tell you why the folding exists or what it does at the bottom. What we can tell you is where you are standing. Still, in the dark, at the speed of a light, moving through time at the only rate anything is allowed, 1 second per second, and getting a next moment out of it, which is the only thing any of us has ever really had. Sleep well.